Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all the student of class 11 for our chemistry lecture. Chapter number 7, that is modern periodic table. This is our lecture number 14. Today we are going to study periodic trends in chemical properties. The most fundamental chemical properties of an element is in combining power. Here the elements will be in combining power. This property is numerically expressed in terms of valency, which is also known as valence. Valency of an element indicates the number of chemical bonds that the atom can form, giving a molecule. Whatever be the valency of an element, it will form that numbers of chemical bond. Okay. Another frequently used term related to valence is the oxidation state, which is also known as oxidation number. Valence does not have any sign with it. Means if suppose the valency for oxygen is 2, it will not have any signs either positive or negative. But oxidation numbers can be either positive or negative, which is decided by electronegativities. We have studied what is electronegativities of an atom that are bonded. So student, we are going to study the periodic trends in chemical properties for valency. So periodic trends in valency. Valency of the main group element is usually equal to the numbers of valence electron. So, how many electrons are present in the outer shell? That is your valence electron, valence shell. So, that particular elements or that particular group element is usually equal to the numbers of valence electron, or equal to difference between 8 and the numbers of valence electron. You take a number 8 and how many valence electron are present? Suppose 6 valence electron are present. Subtract 6 from 8, you are getting 2. 8 minus 6, you are getting 2. So that many numbers of valence electron will be there. We are going to study table 7.6, which show the periodic trends in the valence of main group elements by taking example of hydride and some oxide. As we may be noticed from table that the valence remains the same down the group. Down the group, group 1 will be having the elements of group 1 will be having the same valence electron. And across the period, we will see a gradual variation as across the period atomic number increases from left to right. So let's see table 7.6. Group 1. Its general outer electronic configuration is NS1. Fine. So how many numbers of valence electron is present? It is 1. So its valency will be 1. So it will form that particular elements will form one bond with the another atom. Okay. So your lithium, when it has been reacted with hydrogen, it will form one bond. So lithium hydride, sodium hydride, potassium hydride. Now formation of formula for oxide, when these elements will react with oxygen, it will form lithium oxide, sodium oxide, potassium oxide. Right? Now for second group element, you see its general outer electronic configuration is NS2. So how many numbers of valence electron is being present? It is 2. So its valency will be 2. Fine. So similarly, it will react with 2 number of hydrogen. Okay. Beryllium hydride, magnesium hydride, and so on. For Group 13, its general outer electronic configuration is ns2np1. So how many numbers of valence electron is present? 3. So its valency is 3. Okay. For group 14, its general outer electronic configuration is ns2np2. So how many numbers of valence electron are present? 2 plus 2, 4. So 4. Its valency will be 4. Fine. For group 15, general outer electronic configuration is ns2np3. So how many numbers of valence electron is there? 2 plus 3, it is 5. So its valency will be 5. As well as we have studied that 8 minus numbers of valence electron, it is near to the group 18. So 8 minus 5, 3. So it having 2 valency. One is 3 and another is 5. Group 16, its general outer electronic configuration is ns2 and p4. So how many numbers of valence electron is present? 2 plus 4, it is 6. So its valency is 6, as well as 8 minus 6, we are getting 2. So it contains 2 valency. One is 6, another is 2. Group 17, its general outer electronic configuration is ns2 and p5. So how many numbers of valence electron? 2 plus 5, it is 7. So its valency is 7, as well as 8 minus 7, we are getting 1. So group 17 elements containing 2 valency, one is 1, another is 7. Group 18 element, that is a noble gas element. Its general outer electronic configuration is ns2 and p6. So it containing how many numbers of valence electron? It containing 2 plus 6, that is 8. Group 18 elements, as we know, group 18 element, that is your noble group element, they are completely stable. Fine. So its valency is 0. In this way, we are going to find out the valency of some of the group which has been given in your syllabus. Let's move forward towards the periodic trends in metallic and non-metallic character. As earlier in the table, in a previous lecture, we have studied the modern periodic table in detail. In that, we have studied some of the elements are metal, some are non-metal, some are metalloids. So the metal, non-metal and metalloids, they appear in separate region of modern periodic table. As we know, metal on the left hand side, non-metal on the right, and metalloids along a zigzag line separating the two. It means separating the metals and non-metal. Metals are characterized by good electrical conductivity, and they have the ability to form compound by laws of valence electron. As metal, they are having good electrical conductivity, and they lose the valence electron and get converted into cations, while non-metal are characterized by their poor electrical conductivity, and they have the ability to form compound by gain of valence electron in valence shell. Here, non-metal is opposite of metal. They are poor electrical conductivity, and they gain the valence electron in their valence shell. These terms can be explained in terms of ionization enthalpy and electron gain enthalpy. We have studied what is ionization enthalpy and what is electron gain enthalpy. So here the ionization enthalpy decreases down the group. We have studied the ionization enthalpy decreases down the group. The tendency to lose a valence electron thus increases down the group, and the metallic character increases down the group. As we move across down the group, the metallic character increases down the group, whereas ionization enthalpy increases across the period, and so consequently metallic characteristic decreases across the period. So here student, the ionization enthalpy increases across the period, and consequently metallic characteristic decreases across a period. So electron gain enthalpy became more and more negative across the period, and it tends to be less negative down the group. So non-metallic characters increases across the period. As we are moving across the period, non-metallic character increases and it decreases down the group. Fine. So in the modern periodic table, non-metallic character increases across the group and down the group it decreases. Let's see the problem. Germanium, sulfur and boron belongs to the group 14, 16 and 17 respectively. We are supposed to predict the empirical formula of the compound. Those can be formed by germanium and sulfur and second germanium bromine. Let's see the solution. From the group number, we understand that the general outer electronic configuration and numbers of valence electron and valencies of the three elements are. Elements, germanium, it's belong to group 14. So its outer electronic configuration is Ns2, Np2. So numbers of valence electron here it will be 2 plus 2, 4. So its valency will be 4. Whereas for sulfur, it belongs to group 16. Its outer electronic configuration is Ns2, Np4. So its numbers of valence electron is 2 plus 4 will be 6. So its valency is as it is near to 8. So 8 minus 6, it will be 2. So it having the valency 2. Whereas bromine, it belongs to group 17. Its general outer electronic configuration is Ns2, Np5. So it containing numbers of valence electron 7. So its valency will be 8 minus 7, that is 1. Fine. Germanium, its valency is 4. Sulfur, its valency is 2. Bromine, its valency is 1. So let's see. Sulfur, as between sulfur is more electronegative than germanium. Therefore, the empirical formula of the compound by these two elements is predicted by the method of cross multiplication of the valencies. Element G, valency is 4. Its formula Ge2S4. While for sulfur, symbol is S, its valency is 2. We are cross multiplying it, Ge by 2 and S by 4. So its formula is Ge2S4. While its empirical formula is divide by 2, we are getting GeS2. Okay. So Ge, its valency is 4. S, its valency is 2. Formula is Ge2S4. So germanium, Ge2S4, its empirical formula is Ges2. Let's see the second. Bromium is more electronegative than germanium. The empirical formula of the compound formed by these two elements is predicted by the method of cross multiplication of valencies. Similarly, what we have done between sulfur and germanium. The element germanium, its valency is 4. For bromine, its valency is 1. So we are cross multiplying it, germanium by 1, bromine by 4. That formula is GeP4. So what is the formula? Similar is the empirical formula, GeP4. So here student, in this way we can find out or we can predict out the formula and empirical formula of the elements, okay, and their compounds. So here student, we have completed the chapter. Hope you all have understood. Inshallah, in our next lecture we are going to start the new chapter. Till then, take care, study well, do your best student. Thank you.